Greetings and welcome to this module on basics of digital electronics. So in this session, we are going to see about what is meant by digital electronics and how we are going to realize the basic things using Python. That is the main of this course. And the digital electronics usually operates on the principles of discrete values. That is, uh, it is used for typically representing binary numbers. Binary numbers in the sense it is either zeros and ones. So actually, while development of systems, there are two types of systems available. One is called analog system and another one is called as digital systems. So here I will write that analog and digital. These are the two systems available in the while studying about generally about systems. So analog system usually deals with continuous variation of time. You can see here continuous variation of time. So if I want to measure time period from inch by inch manner means it is very difficult. So if I ask one scientist to record the time in between in 1 second, how much variation occur between 31 degrees Celsius and 32 degrees Celsius means that require very complex hardware and system algorithms for manipulation or processing this scenario. So what they did is they went into another system called a digital system. In that they discretize the value, that is in between. For example, general example is in between 0 and 1. If I ask how much numbers are available means generally you will tell it as infinite in terms of analog. But if you use the same component 0 and 1, then in between 0 and 1 how many variations are there? If I omit means then you can easily tell that only two numbers are available. So this is the major advantage of discretizing the values. So we are keeping only two things into consideration. Higher values, we are keeping it as 1, and lower values, we are keeping it as zeros. So while manufacturing the digital components, usually which are called as digital systems, those who are those who are mapped with digital terms. What is meant by digital term? That is which are all operating with with reference to the discrete numbers. So while we are using laptops or mobile phones or any other equipments, inside that equipments we are having one thing called microprocessors. These microprocessors are mapped with only two values. One is 0, you can have it as low value, and 1 we can have it as high values. So this is a blueprint given to the world by the scientist. So whoever is going to prepare a architecture for microprocessor or anything, you have to follow this blueprint that contains only two terms. One is 0, that is treated as high value, and 1 which is treated as low value. Advantage of this mapping is noise resistance, and you can able to process at higher rates, since we are able to going to process only two numbers, zeros and 1, instead of infinite numbers. So what they are doing is they are going to prepare one ready-made template or blueprint for manufacturing any microprocessors. So those who are adaptable to that policy, they can go ahead with that blueprint. Since they are going to print that blueprint and they are just going to map the components according to their wish. But universal mapping is 0 stands for high, 0 stands for low, and 1 stands for high. This is the universal mapping. Suppose if I want to go with some other number system, suppose I am asking 2, for example, 2 as low and 3 as high means, then what about 0 and 1? The question will come. So the architecture we need to remap once again. That is nothing but very complicated process. In order to avoid that only, they taken only two numbers. One is 0 and 1. Before that and after that, we cannot able to imagine other components, since these two values are universally accepted that 0 stands for low and 1 stands for high. Based on that only, this entire digital electronics is built up and still now in use. So mainly these are useful in processing, data processing and signal storing information. In that scenario, these all things are useful. So now we are going to see what is meant by number systems in digital electronics. So when we are coming with 0 and 1, we have to do manipulation. So usually in this day-to-day world, we are using decimal number system that comprises of numbers from 0 to 9. So any number you writing commonly will be fall inside this group that is called as decimal numbers, that is used in everyday counting and arithmetic operation. Wherever you are using, this decimal number will come. And this binary number means this is used especially in digital system, and wherever you are doing computational process, this binary number system will come. That contains only two numbers, that is one is 0 and another one is 1. One is 0 and another one is 1. Only two numbers, the base value is 2, since it contains only two numbers. Here the base value is nothing but 10, since it contains 0 to 9. If you count the total, you will get 10. And hexadecimal number is nothing but the range of 0 to 15, that are called hexadecimal number. And octal number is nothing but 0 to 7. In this group, which are all available, that are called as octal numbers. So usually maximum this binary number is used for many of the computation. And apart from that, many different system and any encoding systems, they are following octal for data representation, encoding and decoding purpose. We are using this octal number system for any secret information or any other things that should not be recognized by the real world. In that hacking, in order to prevent from hacking, they are using different number system. That processors mapping level will be somewhat different. That will not follow our usual protocol. So they are using some specialized processors that may differ from this binary number system. So inside that, embedded processors are available that are using hexadecimal system for coding and embedding, and the other things are there. So that we are going to see deep in this digital electronics protocols. So for decimal number, the base value is 10. For binary, the base value is 2, and octal, the base value is 8, and hexadecimal, the base value is 16. This is what we are following. Now we are going to see some of the workouts, and we are going to see how it is going to helpful. So these annotations I am keeping for our reference. So if you want, we can, I already share you this all the PPTs in the course description. If you want, means you can refer and you can understand it. For workout purpose, I am going to make use of this note. So here I will do the workout and we will go into the realization part in a short span. I am taking the data called 125. This 125 to the base 10. If I write means this is called as decimal number system. If I want to convert it into binary, then I have to do like this: 32 remainder 1. This is 61. This is what? Not 61. This is 15. Sorry. 1 minute. I will. Okay. I will do like this. So if I divide it by 2, so this is called a decimal number system. If I want to convert it into binary, then the binary value will have base 2. That base 2 should be used as a remainder here. So 2, that is nothing but 6 2s are 12, 2 2s are 4, balance 1, right? And then again I am dividing this. This is nothing but 31 to the balance is 0. And another one is 15, remainder is 1. 14, balance 1. 3 2s are 6, balance 1. 2 2s are 1. So you have to write from bottom to top. So 1 1 1 1 1, 5 ones, 1 2 3 4 5, followed by 0 1 to the base 2. Now you can visualize, other than 0 and 1, no numbers are represented here. That is called as binary number representation. This contains only group of zeros and ones. So another form of representation is directly you can, instead of conversion like this, you can directly write the numbers, but in a short span. So you can write like this: 2 power 0, 2 power 1, 2 power 2, 2 power 3. That means 8, 4, 2, 1 will come. So directly you can write 0 as 0, 0, 0. No numbers are available. 1, if I want to write 1 means 1 is available here. So directly you can write 1 here. If I want to write 2 means 0, 0. Wherever 2 is available, you put 1, remaining all 0. 3 means 0, 0, 1, 1. That is 2 plus 1 is 3. 4 means 0, 1, 0, 0. 5 means 0, 1, 0, 1. Like that you can write up to 1, 1, 1, 1. That means 8 4s are 12. 12 plus 2, 14. 14 plus 1, 15. Like that up to 15 you can write directly. So if a number is within very small span means directly you can use 8421 coding method and you can directly write. Otherwise you can divide by the corresponding base and you can write directly. So next thing is I am taking the same number 125 and if I convert it into octal number, octal means nothing but base is 8. So I need to divide it by 8. So how to write means 125. How it is possible? If I divide it by 125, what answer I will get? 1, remaining 4. That is 8 5s are 40, remaining 5. Like that you will get. Okay, 40. Sorry, this is 5 8s are 40 now. 188, balance 4, 5 8s are 40. Remainder is what? 5. So I will get 155. Randomly, you can check. 125 means remaining 5. So that is nothing but 155 to the base 8. So this is how to convert a decimal number into octal number, like that. So here, whatever I am doing, we have to realize that by using a Python coding. That is the very, very important. So how to realize that by using Python? Let us check. Before going into that, let us check what is meant by a hexadecimal system. Hexadecimal system is nothing but base is 16. So you need to divide it by 16. So if I get one number means, if I divide it, this means what I will get? 1 0. So 0 is 0, 1 is 1, 2 is 2, 3 is 3, 9 is 9, 10 is 10. But here also you are getting 10. Here also you are getting 10. Then confusion is coming whether to write 16 as 10 or original 10 as 10. So what I am doing is, what scientist did is, this 10 is represented in terms of alphabets. 11 as B, 12 as C, 13 as D, 14 as E, 15 as F, and 16 as 10. So whenever these numbers are coming as balance, you have to write in the term of ABCD, not like these things. Suppose if I am writing 1101, then what is, according to 8421 coding, the answer is what? 13. 8 plus 4, 12, 12 plus 1, 13. But 13 should not be written as 13. It should be converted in the form of D. So it is D to the base 16. These are all the things you have to keep it in mind. So parallelly, I will go into Python coding part so that you can able to understand this. So for those who are beginners, they have to search Google Colab in the Google, and then you just you will get here like this Google Colab. If you open that means, if you already have account, it will directly lead you there. Welcome to Google Colab. If you are the first term user means you have to create one account. That is just nothing but a normal Gmail account you can create and you can use that for your Google Colab opening. So first you have to get this screen, and after that you have to go into file and you have to create a new notebook in the drive. If you click new notebook means it will lead you into this page that is nothing but untitled PyNB. That means interactive Python notebook. This is nothing but a normal, like a calculator only. 2 plus 3 if you type means, if you click connect means it will connect into Google Clouds and it will give you the results here like that. So once you created this notebook means, my advice is first step you create this notebook and keep it as ready. And whatever you are seeing here is called as snippets. Snippets means where you can write your codings. Okay. So here I am having some stuffs. Let us check one by one. Interactive steps that I will explain you later. First, a simple program we will see here. So here I am going to do all the things what I have explained here: binary, decimal, hexadecimal, octal. So here this program is very simple. Definition I am writing. So those who are very first users of Python, they need to go a simple basic steps before coming into this course. Since this course is, if I start the scratch level means, then again new course has to be created. So this course is only for a little medium level beginners. So otherwise you no need to worry about these things. One small video how to use Python if you read means, then what are all the things I am describing here, everything will be pretty clear to you. First I am going to write a definition. Definition is nothing but a general theme. I am going to do one calculator that is going to do the conversion. So this name can be user defined. You can use any name here. Following operation I am going to do: binary to decimal, decimal to binary, binary to hexadecimal, hexadecimal to octal. Anything you can realize. And this enumeration is nothing but the following operation we are going to do in the below upcoming step. I am going to carry over here for that purpose. So in the output page, you can see what are all the lists I am mentioning here that will come out. So here I am going to give the input base. So from which number system you are going to convert to which number system. So that is not from binary to decimal means, here you need to give binary, and in the output base same thing you have to copy and you have to enter the same thing there. It will get you input. If you type hexadecimal or decimal means, correspondingly that operation will be carry over. So here I am getting one numerical in the form of string I am getting. Why means I am going to type this number and this number will be carry over further into string based operation. And after that we are going to convert that once again from string to number. So that is the thing. While carrying over, we have to get that number in the form of string. Then only we can able to avoid a mistake. Otherwise, it will encode and it will assemble into some. It will resemble into some other form. So in order to avoid that over encryption or unavoided coding, I am going to use that string component so that it will treat that as a string. And which are all the trailing and leading spaces, it will strip off. And based on my input base, if it is binary means that will be converted into that corresponding string will be converted into number here. Okay, so similarly, that is base 2. I can give here. This is the input. If I want to convert this means, this is the default thing available in Python. That is number string comma 2 means it will converted into binary. Number string comma 16 means it will converted into hexadecimal. Number string comma 8 means it will converted into octal, like that. So you have to just clarify. Decimal is default, you no need to mention 10 here. So input base is equal to binary means you have to 2 means it will consider only 1010 only. Other than this, if you enter means it will give you wrong results. So output base is binary. If I give means, here I am giving one word called 2 colon. Since in the output you will get 0b extra, that means binary representation. But usually 0b we don't need in the output, since everyone know 1010 is the binary format, and this 0b is coming means it will be confused unnecessarily. In order to avoid that, I am keeping 2 colon. That is nothing but this is optional only. If you want, you can use, otherwise you can omit that. But in the result window, you will get this 0b additionally. That is not required. So if I give binary means, you will get these two portions will be clipped off and you will get only corresponding results like that. So finally, you will get all these things, and finally my main window will calculator off means you are calling this function. So this function will start executing. This is called as definition based program creation. Okay. Throughout this course, we are going to use this definition based model building only. Okay. So now I am going to run this program. If I run this program means it will ask you what is the input base. So I am giving decimal here. So before that, I will recall you what are all the things what we are going to realize. If I give 125 means what answer you will get? 5 1 1 2 3 4 5 1 1 1 1 1 0 1 to the base 2. That should be your answer. So here I am going to give decimal, and here I am going to get results as binary. So here I am going to get 125. I am giving input. So if I give enter means what you will get, I am getting the answer as 1 followed by 0 1, which is nothing but by binary number. Okay. Similarly, once again I am running here and I am giving same what I am giving 125, right? So for that I am giving this as decimal. Okay, and I am going to convert this into octal number system. Octal. So what is the number? 125. Okay, so what will be the answer? Answer is nothing but 175. 125 if I convert means 175 is coming. How it is coming? Let us recheck. So whatever I am did at the time is wrong. I have written 155, but here it is coming 175. Why means here how it is? Here 7, here 125 to the base 8. So I need to divide it by 8. So how it is coming means here how it is coming you can realize how you will get the results you can realize. So 125 divided by 8 means simple calculation you can do and you can realize the results. So answer is nothing but 175 to the base 8. Since here if I get wrong results also, you can able to realize that by using your simple Python collaboratory learning method. That is the advantage. So here you can see the correct answer is 175 to the base 8. That is the thing. So sometimes you don't believe this code also. Sometimes it may create wrong answers. So better realize that with your manual calculation. This is just for cross-checking purpose. This is realization. Don't believe that this will give accurate answer, since it will be sometimes our coding may be somewhat missing. At that time, it will return some results that may correct or not. Accuracy level is that much not guaranteed. So better you have to go ahead with your own manual calculation and verify with some other method. So how to verify means what is the best method means I will tell alternate method. Whichever is coming, we will check. Already we have created 1111101. This is the binary. So now I am going to convert binary to octal. Binary to octal. How to convert binary to octal means 2 power octal means 8. So 2 power 3 is nothing but what? 8. So from the right hand side, you need to group the number into 3 groups. That is nothing but this one, this one, this one. 1, 2, 3, 1, 2, 3, and 1. So padding, I am adding 0. So now I impose, now 8421, this 8 is cut out. So remaining 421 will come. So I am posting here 421, 421, 421. 421 is nothing but 4 plus 1 is 5. 4 plus 2, 6 plus 1, 7. This is 1. That is nothing but 175 to the base 8. So which one is correct? You can realize. So 125 to the base 8. If I do some mistake also, you can able to realize how it is coming. That is the simple thing, right? So so this direct calculation will also give the results. Some indirect calculation also you will get the results. But once you are doing such mistakes, unfortunately, by force you are doing some mistake also, you can able to verify whether my manual calculation is right or wrong. If it is coming wrong means once you go ahead and recheck with your results. That is the okay. So here, so it is very simple only. So you can realize any number system by using any number system. So whatever I am doing here, you can realize any number system to any number system. For example, already I have teach you in the notebook, that is 1101. What is that 1101 means? Here I have given here 1101. So this 1101 is nothing but how much? So if I impose means 8421 will come. 8 plus 4, 12 plus 1, 13. If 13 is coming means we should not write 13. You have to write A10, B11, C12, D13. So D to the base 16. So answer should come as D. So let us check that here. So I am giving here decimal binary. Okay. And then I am giving it as hexadecimal. And then I am giving 1101. So what will be the answer? Answer is D. This is how you can able to realize the things with your own understanding, right? So here the Python is used to realize different types of number system, and one more number system also we will do for better understanding. For example, 1101. This is binary number system. This I am going to convert it into decimal. Direct method is what? 8421. That means how much? 13. Hexadecimal only you have to keep it as D. 13 is nothing but 13 only. 13 to the base 10. So the same mechanism, if I give decimal means how it will react, let us check. Okay. So here what I am doing is first I am giving binary. After that I am giving decimal. And then I am giving the same number. So what is the answer? 13. So whatever we are doing is correct. In that manner, you can able to realize any number system using your own calculator instead of using going ahead with already available online tools or using thing. You can develop your own calculator. The advantage here is what is the thing is you are developing your own code. Also, you are realizing one topic what you have learned in your theory. Whatever we are telling, even though it is wrong also, you can recorrect it by using this collaborative learning. Okay, so earlier what we have did, this 125, if I divide it by 8 means by oversighting I did one mistake. What is the mistake? 8 fours are 12. Like that I have did. So but what is the thing is 8 fours are not 12 now. So what I have to do here, 1 8 is 8, balance 4. Okay, so 8 4 45. So 5 8s are 45. Again I am doing oversighting mistake only. Remaining 5. 155 will come. In examination, this question will come means everyone will write 155 only. Most of the cases, what we have verified, everything they did the same mistake. But what is the real mistake? You write it in the comment. You write it as a comment. Where is the mistake? Whatever I am doing is correct or not? 1 8 is 8. 2 8s are 16. So 1 8 is 8, balance is 4. 5 8s are 40, 6 8s are 48. So 5 8s are 40. Remainder is 5 only. So 155 is correct, but I am getting 175 as answer. How? That is your comment section. You have to comment where is the mistake. Okay, well, but when I am doing the system, it is giving the result as what? 175. 175, which is correct. Decimal to octal. Decimal to octal. Okay. So, but 175 is only the correct. We have realized this. In another form, we have realized this. But where is the mistake? Those who are studying this course, please realize and comment yourself. If you are getting the correct answer means you are coming into the line of learning. So this is where the realization works you well. So where the realization works you to find where is your mistake, what mistake you are doing, like that you can study. So in the same manner, we can able to realize logic gates also, AND gate, OR gate, NOT gate, XOR gate, XNOR gate, everything we can realize. But what is meant by logic gates, how they are going to work, in what manner we are going to realize, that I will give you in a separate module. Next module, we are going to see how to modify this program so that this calculator can able to work for realizing logic gates. So what is meant by logic gates, how to realize that we will see it in the next video. So up to that, everyone keep continuing learning, learn by means of realizable manner, so that even small mistakes can also be, you can able to rectify easily. This is what the outcome of this course. Thank you everyone. We will see on in the next lecture by means of realizing logic gates by using the same program. Thank you everyone.